Good morning to all students. So, in the last two lectures of automation and control, we have studied basics of automation, then basics of relays and contractors. In that types and working we have seen. Also, we have seen the difference between relay and contactor. So, today we are going to learn the next part of our first topic, which is important as far as every point of view, in point of view of exam, also in point of view of knowledge. So today we are going to learn introduction to programmable logic controller, which is called as PLC. So PLC is not a concept, okay, it's a device which is used in automation industries in order to reduce number of iterations and number of complicated wiring for a particular performance of a task. That is what a basic PLC means. It's a device, by the way, it's not a concept or a theory. So according to the NEMA standard ICS 3 1978, PLC can be defined as a digitally operating electronic apparatus. Okay, it's an electronic device which uses a programming memory for the internal storage of instructions. It has a programming memory, okay, of some storage measurement for the internal storage of instructions for implementing specific functions. So basically it's a device which is electronic. It has a programming memory for the storage of instructions. Instructions means commands or program or codes for implementation of functions like logic functions, then sequencing, then timing functions, counting functions and arithmetic functions to control through digital or analog modules, okay, which can be controlled through digital or analog modules, comma, various types of machines or process. So these codes which we are using in the PLC programming are used to control various types of machines or different processes in industries and very different applications. Or it in simple language, PLC can be also defined as a device that is pre-programmed to accept relay ladder logic instructions and perform these instructions to control the equipment operation. So it's basically a device which is pre-programmed. Programmed is installed in the device or driver from the start. For example, when we are going to buy a mobile, we are getting any mobile, for example iOS or Android or other for Firefox operating system mobile, they are giving us inbuilt software mobile, okay, we don't need to install any software on that particular mobile, like unlike the laptops and PCs, okay, whenever we are going to buy a laptop or PC, we have to install a particular operating system or DOS, okay. It's not like that in case of mobiles, also it's not like that in case of PLCs, okay. So they are pre-programmed to accept relay ladder logic, okay. This ladder logic you are going to study in the next chapter or in the end of this chapter instructions, okay. These are quite interesting to perform, okay. So PLC terminologies. So sensors, in case of PLCs there are different sensors like switches, flow sensor, level sensor, pressure sensor, temperature sensor, transmitter, etc. So PLC consists of, I'll show you basic diagram of a PLC. It's not here right now. So after sensors, PLC basically consists of sensor, then output devices, then central processing unit, then ladder diagram. 4 to 5 components are there in every PLC. So first one are sensors, which are required to sense a particular quantity to be converted into electrical quantity or different quantity. Okay. So there are different sensors like switches, on off switches, relays, etc. Flow switches, flow sensors which identify the flow. Level sensors, for example, ultrasonic, ultraviolet sensors which are level sensor, or proximity sensors also used for level measurement. Then pressure sensors which convert the pressure into temperature, P2I. Then temperature sensors or transmitter, etc. Then output devices. Okay, output devices or actuators are motors, valves, solenoids, lamps, or audible devices. So the PLC is using these sensors, then the programming with the help of CPU to control these output devices. For example, sensor, this has one PLC input, okay, push button. Then actuator, there you can see here PLC output is given. This is a flow diagram where this push button is a sensor. It is given, the output of this button is given to the PLC input. Okay, then it will program according to the ladder logic, relay logic. Then it will create an output or a command which is called as PLC output 1, which is given to the motor starter, which is actuator or contactor, then given to the motor. Okay, these are analog type. These are digital. Okay, normally open, normally close. I'll zoom it. Normally open push button, normally close push button, normally open switch. These are different sensors which are given to the PLC inputs. Also analog inputs like level transmitter. Okay, you can check the level of the water contained in a tank or a vessel. Then we can give the measurement, exact measurement to the PLC inputs. Okay, then digital, these are the digital inputs. Then digital outputs are light is digital output. Analog output is nothing but for example, meters, analog meters, and different current to pneumatic transducer. Okay, here this output from the PLC is in the form of current. Okay, then we have to convert it into pressure. Okay, so C to P or pneumatic, current to pneumatic transducer is used. Transducer, as you all know, that it's a device which converts any quantity, physical quantity, into electrical quantity. Okay, so here we can use, this is an basic example of air pump. So now main parts, which is central processing unit, CPU. CPU is a microprocessor that coordinates the activities of the PLC systems. Okay, there are different activities in the PLC system which are monitored and coordinated by the use of CPU, and it is a microprocessor. Okay, so it's quite similar to that of the CPUs which are using in the PCs. Okay, personal computers. It executes the program, process input output signal, and communicates with external devices. The main working of this CPU is to execute the program which is considered by the input, then process input output signals. Okay, amplify and process, and then communicates with external devices. Okay, so it's, the CPU is an integral part of any system. It is called as an heart of the system. Okay, it takes an input and gives a particular output depending upon the programming. Then the ladder diagram, which is the most important because we have to construct our code or program in this ladder diagram, by this ladder diagram. Okay, so ladder diagrams are specialized schematics commonly used to document industrial control logic system. Okay, Schematics means it is a schematic diagram which is specialized, and these diagrams are used to document industrial control logic system. Okay, by using the ladder diagram we can control the different logic systems. They are called ladder because they reassemble a ladder with two vertical rails, which means that it is quite identical to a ladder which having two vertical lines supply power and as many horizontal lines as there are control circuits to represent built from the relays. Okay, so this you are going to see in the next points. Okay, so background of PLCs. So before going through the background and this part of the PLC, I'm going to show you a lecture or a simple video so that you can which are having visual effects. Okay, so I'll show you. You just listen to it.
Today, we are going to talk about the basics of a PLC, the workhorse of industrial automation.
So this is a visual video of a PLC.
Before we get into today's video, if you love our videos, be sure to click the like button below and make sure to click subscribe and the bell to receive notifications of new Real Parts videos. This way, you never miss another one. The Programmable Logic Controller, or PLC, is a special purpose computer. It has no display, no keyboard, no printer, no hard drive, and hides in the control panel out on the factory floor. But it is still a computer. Initially, the PLC was a replacement for panels of relays, devices that turn on and off. Making a machine run using relays as logic was time-consuming and challenging, and making a change in the logic or the operation of the machine was almost as complicated as starting over. Relays also fail far more frequently than computer components, so that relay logic required more downtime to keep it running than newer PLC-based controls. On top of all of that, relays use a lot of electricity, make lots of heat and soot, and take up lots of space.
So basically, PLC is a replacement to the relay drivers and circuits, which are very time consuming and having very high computational wiring and iterations.
An installed PLC is deceptively simple in appearance. You have a CPU module and input-output devices referred to as I/O. Sometimes the I/O is part of the CPU, and sometimes it is in other modules. The CPU communicates with the I/O, so in most systems, they share a backplane that physically holds them in place and electronically connects them. In other equipment, the I/O modules can be miles away from the CPU and connected with data cables, so that the PLC is not limited to a single cabinet or even the same building. Since the PLC is a computer, there is no need to limit it to only digital inputs and outputs. Over the years, the manufacturers added analog and other numerical inputs and outputs. To make these numerical devices useful, they included calculation capability in the programming as well, so that we can now calculate, for instance, statistical process control, or SPC values, and put PID controllers directly into the PLC program. Since this is called a programmable logic controller, we need to program it. Most PLCs are programmed using an application running on a standard desktop or laptop PLC. They communicate.
So as you can see here, PLC has a software, PLC and data acquisition, SCADA. So we have this kind of software in our lab for a demo purpose, for experimentation. We are going to see it later. But basically what I want to say is, it is using a simple programming capability with the interface to the hardware. Okay, we have to give coding according to our application with an interfacing device. This is nothing but DAC, data acquisition control. This is PLC software. This is hardware.
Communicate with the PLC using Ethernet or proprietary communication bus, depending on the manufacturer. Most manufacturers seem to have settled on Ethernet and/or USB in recent years. Unfortunately, the PLC manufacturers have failed to agree on how we program the control logic. Although most of the manufacturers claim some form of ladder logic, the specifics of that language are different for each manufacturer.
So now you can see here this diagram, this whatever figure is, it's a circuit, it's basically coding figure. Okay, here you can use ladder logic in order to turn the switch on and off according to the application. So as in this PDF they have said here why it is called as a ladder. Okay, two vertical rails and horizontal lines. Vertical rails means supply power, horizontal lines means these control circuits. Okay,
Sure. Including different capabilities, different ways of doing the same thing, and even differences in the order in which the CPU processes the various pieces of logic. One attempt to bring some order and interoperability to this chaos is the IEC 61131 standard from the American National Standards Institute, or ANSI. The excerpt from the ANSI webpage shown here gives a flavor of what is there. The IEC 61131 standard defines several programming languages with different strengths and weaknesses. Local programming standards, your boss or the customer, will usually specify what language you use. That wraps up this short discussion of the structure of PLCs. I hope you enjoyed this little introduction to the underlying architecture of many industrial control systems. Keep watching as we continue our exploration of the basics of industrial.
so that particular visual video I think had made you more clear about the introduction to the PLC. So after going to just the introduction of PLC, we are going to see the background of a PLC, where it came from. So the need of PLC means how it is invented. As we know the fact that necessity is the mother of invention. Okay, so how PLC was required means what is the need which invented the PLC. So first of all, it was a low cost. Then the system should be intelligent. Then the controller which should be easy to control. In case of before PLCs, there were controllers like PID controller and fuzzy controller. Even they are now existing, but these are quite hard in order to program or in order to optimize. So they required a logic controller that ensembles all the different controllers like fuzzy controller, neural logic controller, artificial intelligence controller, then particle swarm optimization. Okay, algorithm, different algorithm we can combine in PLCs and we can give the output to a particular device. It is what is very useful in case of PLCs. So that is the need which invented the PLC. Okay, the first PLC was designed by a team of engineers at the company General Motors. You know the this company GM, General Motors. Okay, which are producing the Rolls Royce car, okay, which is the most, I think the most expensive car in the whole world in the year 1968, when the company is looking for other methods to replace the complex system of relays. As I said earlier also in the video, it is invented to replace the system of relays, which is very complex wiring and iterations. They also set the specifications of the new control system, okay, which are meeting the following requirements. Okay, these are the requirements which are going to be met by these PLCs. So it is easily programmed. There is no need for rewriting if there are changes on the program. Okay, you can alter it on the way. They are smaller, cheaper and higher reliable. Okay, simple in building. Okay, and the maintenance cost is very cheap. Okay, and then cost competitive. Basically, it's a low cost, intelligent system and easy to control. So now we are just going to introduce the functions and type of construction. So different functions of a PLC. PLC can perform various functions. Okay, for example, sequence control. So what is a sequence control? It's a type of control which is having functions like conventional logic, timer or counter, then substitute PCB control card, then machine and process controller for automatic, semi-automatic and manual. Then type of control such as advanced control. Okay, so advanced control, there are different functions like solving mathematical operations, okay, then managing information, then analog control of temperature, pressure, etc., then servo motor control, stepper motor control, then controlling PID. This is what we are going to study in our whole syllabus, controlling the different controllers by using the PLC. And supervision control, so it includes the process display and alarm, diagnosis and display fault, interface with the computer, then interface with the printer, then factory automation network, LAN, then WAN, widespread area network, and etc. Okay, so types of PLC construction. So there are three different manufacturers you can see here. First one is Mitsubishi, then Siemens, etc. So advantages of PLC. There are different advantages of PLCs. Okay, first one, the implementation of a short control project. Okay, then programming can be easily changed. Accurate calculation of the cost project. Okay, then it requires a very short training time because ladder diagram logic is not that difficult. Then flexible control system design using the software. Then a wide range of control applications. Then easy maintenance is what we are going to get to the PLCs. Then high reliability. After that, a standard hardware controller. Then resistance to the problem of the environment. Okay, so external disturbance is quite impossible in case of PLCs because external disturbances like temperature, moisture, voltage instability is not good for a particular system to work on. Okay, next, for this lecture we are going to stop here and we are going to continue it on the next lecture. So till then, watch the video, and if you have any complaints or any doubts you can ask. Okay, in the first two lectures I have given the introduction part, and this lecture is also for introductory part of a PLC. If you have any doubt you can ask. I have uploaded the video on YouTube, and also I uploaded the PDF in your Teams. So do watch the video, and if you find out, please clear it. Take care.